Okay, hey everybody, Dr. Urban again. I'm going to go over problem 320 or something similar to problem 320 from your homework. Okay, so we know that there is something, I'm not going to use all the words, but there's a hill and that hill is at 9 degrees. Okay, I think the problem says someone is moving along a ski run, or moving along as a flat area, and they have attained a velocity. Okay, so we know that, and then they're going to go down a 9-degree hill. Okay, and what we're asking is how fast they're going once they've gone down 140 meters of the hill. Okay, so what we have is a velocity here that is given as 9.2 meters per second. And then we're told there's going to be a 9-degree hill. I've exaggerated it, obviously. There's going to be a 9-degree hill, and that 9 degrees is here. Okay, that's how that angle would be measured. And then whatever this is, the person is going to have 9.2 meters per second at the top of the hill, and then they're going to take the hill and go down, some distance of 140 meters. And what we want to know is right here, what is this velocity, question mark. So that's what the problem sort of walks you through. So we know there's a hill at 9 degrees, okay? We know that the initial velocity is at 9.2 meters per second, okay? And then we know as we're going down the hill, it says we go, or the person goes, or the thing goes 140, mine says 140 meters. Okay, so do you remember when we talked about how do we get, and then we want to know what that final velocity is, or the velocity after this distance, right? So how are we going to be able to find that out? So we talked about in the last class, and definitely there's a great example of this in your chapter 3 slides, but normally we think about this as being the X and Y axis. But when we have a hill, what we're going to do is we're going to twist the entire thing up 9 degrees. So instead of it looking like this, it's actually going to look, this is where my old x-axis was, kind of dotted line. So I'm exaggerating, obviously, but my x-axis is now here. I'm now on a hill of whatever the hill is, theta, like this. That's my y-axis. And there's something that's going to be moving down that hill. And so if you pull up that slide, you will find when we determine, we know that gravity is directed straight to the center of the earth, which is this way. So this would be our gravity. But wow, we're off the axis by some angle, which happens to be the same as that angle. So we're going to have actually 2 components of what the gravity is doing to us. Remember, gravity is an acceleration of 9.8 meters per second squared. But this is going down a hill. It's not like something sitting just right here where we know all of that acceleration, all of that gravity is 9.8 meters per second squared, right? But we're on a hill, so we do feel that, we do know that some of it is directed down the hill like this. So we're gonna have a acceleration down that slope. And then there's going to be a component that is directed into the hill, and that's going to be in the y direction. And that's not the part we need right now. What we need is the piece that's directed down the hill. And another way to actually draw the triangle is to put that x component here. We realize that's opposite the angle, and what we found out in our slides is the acceleration on a hill. And this could be a hill, a ramp, what else? Slide, any of these types of things. Okay, so basically the acceleration on a hill or a ramp is g times its opposite. And oops, sorry, wrong color. So if this is where gravity is, this is the vector for gravity, right? And I have an angle here of theta, then I have the hypotenuse here. Here's the opposite and hypotenuse. They have a sine relationship. So it's going to be plus or minus g sine theta. And the reason we put the plus or minus here is the thing moving as we draw it in the positive x direction or the negative? Well, we're going this is the positive x direction. So it's going to be, the acceleration for this problem is g sine theta. And as I said in class, this is not going to be provided to you on the equation sheet. So you're going to need to know this extra little piece. So the acceleration in the x is 9.8 meters per second squared times the sine of the hill. In this case, it's 9 degrees. And we find out that that acceleration is going to be 1.53 meters per second squared. I take a minute. It's like a 9-degree hill, not too steep. you don't feel like you're going to be zinging down the hill. So if this is what gravity is, the accelerating to the center of the earth 9.8, then it's not quite 2. So it's like not even a third of gravity. Yeah, that kind of makes sense. I know I'm going to go down the hill, but I'm not going to go like ridiculously fast. And it's not going to be like one of those water slides where you just like jump off the edge. Okay, so I know my acceleration. Oh wait, I've got a displacement. Now that we're really talking about this, we realize that we've put the x-axis here, so this becomes the delta x. So I've got initial velocity, delta x, and acceleration. So I'll write that again. My initial velocity is 9.2 meters per second. I have a delta x of 140 meters in my example, and an acceleration in the x of 1.53 meters per second squared. I have this, and I want final velocity, question mark. What of the kinematics equations would I need? I have, basically the question I'm asking you is time in here, and the answer is no. So I use equation 3. So v final squared equals v initial squared plus 2 times acceleration times the displacement. If the displacement is the x, I'm going to have x acceleration, and these velocities will be in the x. So I need to take the square root of both sides. So I have v final equals the square root of the initial squared in the x plus 2 acceleration in the x plus delta x. And let's go ahead and plug in those values. V final equals square root of my initial velocity, 9.2 meters per second. This gets squared. I would go ahead and write what that value is just right above it. So I'd squeeze that number in, 84.63, just so I know what 9.2 is squared, plus 2 times that acceleration I just found here, 1.53 meters per second squared, times however long I slide down that hill, in this case, 140 meters. Okay, and then actually, I'd probably take the step to get this amount, just to make sure I know. Just go ahead and get this separately, 2 times this, and I get 428.4. That's just the way I like to do things, just to, one little math step at a time. So my final velocity, and don't forget to take the square root of all of this. Add these two together, take the square root, and I find out that final velocity is, let's say, it's 22.65 meters per second. So if I'd given this to you, I would have probably given you 2 sig figs. So let's just go ahead and use 2 sig figs. We'll say 23 meters per second for this. I believe, and just be cautious, because if they did want 1, then it would be 20 meters per second. But I think they're wanting 2 sig figs. I don't know for sure, but I think they want 2 sig figs. So there we go.